Today we're going to be learning about inverse functions. Often it is necessary for us to represent a formula or function for undoing the operations that have been performed on a number. The formula or functions is called an inverse function. The inverse function is a function that takes us back to the place where we started before the original function was applied. So some real life examples of that would be if our original function was to sit down and we want to undo that, the inverse would be to stand up. If we have the function of opening a door, if we want it to go back to the original before, we would have to close the door in order to open it. And if our original function was to turn on a light, we would have to turn off the light for us to turn on the light. So those are all functions that have an inverse. So some examples of functions that don't have an inverse. If you crack an egg, you cannot go back to the original egg once it's cracked. Another example is once you cut your hair. You can't just go back to the hair that you had before once it's cut. Unless, over time you grow it back. But immediately after you cut your hair, there is no way to go back to how your hair was before. If you spill a drink, cannot undo spilling your drink unless you refill it, right? So these are examples of functions that don't have an inverse, and then these ones have an inverse. So mathematically speaking, if our original number is 3, and we add 2 to it, 3 plus 2 is 5. If we want to go back to our original number, we would need to do 5. We would need to take the 5, and if we subtract 2, we would get 3. So there is a possible way to go back to our original number. Okay, let's say we started with 5, and this time we multiply. 5 times 4 is 20. So if we take 20, it is possible to undo it and go back to our original number by dividing by 4. Okay, let's try squaring a number. So if we take negative 3 to the second power, that's 9. But if our original number is negative 3, if we were to try square rooting 9, it does not get us back to our original number. So no. So as you can see that certain operations, we have a way to return to the original number. It will have an inverse, whereas some functions do not have an inverse. So functions that have an inverse are called one-to-one functions. A function is a one-to-one function if for each y corresponds to only one x value. Recall that we learned that every x there is only one y. That is used to tell whether something is a function. This is saying a function is one-to-one if for every y there is one x. So it's kind of the opposite of what we've already talked about. And again, what we've talked about is how to tell something's a function. Now we're talking about one-to-one. So if we take a look at example 1 here, we have to look at all the y values and make sure that every y value only has one x value. So determine whether the function is one-to-one and explain. So if we look here, 2 has an x value of 1, so it has one y or x value there. 4 has one x value, 6 has an x value, and 1 has an x value. So yes, because each y has only one x, so it is a function, and it's one-to-one. If we take a look at example 2, if we look when y is 4, it has an x value of negative 2. But if we look over here, when y is 4, it has an x value of 2. So automatically, without even looking at the rest of the points, we know that it is not a function. Every y does not have one x value. So again, when y is 4, it has two different x values. Therefore, it is not considered one-to-one. Okay, so now we're given a table. So we're going to still look at all the y values. So when y is 2, it has an x value of -4, 2, and 4. So this is not one-to-one because every y does not have one x. So each y does not have one x value. When y is 2, it has 3 different x values. -4, 2, and 4. Okay, last one like this. So if we take a look here and we look at the y values, so if we look at this point right there, it has a y value of 2. So this point right here is 3, 2. Then we have another point right here, and this one's at 2, 0. So when y is 0, it has an x value of 2, and when y is 2, it has an x value of 3. But if we take a look over here, this point right there is at -2, 0. So when y is 0, it has an x value of 2 and -2. So this would be no. So each y does not have one x value. When y is 0, it has two x values, 2 and -2. So again, when y is 0, it has two different x values. So that is why it is not one-to-one. So recall that we've learned that the vertical line test determines if a graph is a function. Just like every x, there can only be one y. So to review here, to tell whether this graph is a function, we would draw a vertical line, and if it touches the graph only at one point, then it was a function. However, now we're talking about one-to-one. So to tell if a graph, looking at a picture of a graph, if it is one-to-one, you will use, instead of the vertical line test, you're going to use the horizontal line test. So if every horizontal line touches the graph of a function at no more than 1 point, the function is one-to-one. So again, to tell if something is a function, use the vertical line test. To tell if something is one-to-one, you're going to use the horizontal line test. So let's take a look at example 5. So we're asked if this is one-to-one. So we're going to draw vertical lines, and it can only touch the graph once. So no matter where I draw a vertical line, it only intersects the graph one time. So this is one-to-one. Let's take a look at example 6. So if we draw a vertical line here, we have a problem. It intersects the graph twice. So this is not one-to-one. Now if I draw a line here, it only touches it once. But if I find a spot where it touches twice, it is not one-to-one. So one-to-one, again, if you look, when y is 5, this point right here has an x value of 3, and this point right here has a y value of 5, but it has an x value of -3, so it is not one-to-one. Okay, the last example in your notes, if I draw a horizontal line, it intersects more than once. I found a spot where it intersects more than once, so it is not one-to-one function.